Hey guys, this week in physical geology, we're going to the beach. Yeah, not really. We're going there virtually as we explore beaches and coastal areas. And then later this week, stay tuned for discussions about climate change and coastal areas. All right, so we're going to start with just kind of a basic overview of what the coastline looks like. Obviously, coastlines are constantly shaped by wind and wave action. So you've got kind of an interplay between erosion and deposition happening here at sea level that affects the local landscape and creates really cool landforms. There's also obviously an interplay with human activity, and we'll talk more about that with our real world curriculum connection later this week. And so here is a satellite image of Cape Cod, Massachusetts, and Point Reyes. And both of those landforms are a little bit unique in that their shape is kind of a narrowed, in the case of Cape Cod, it's what we call a spit. And then in Point Reyes is kind of more of a peninsula or a headland. And those shapes are really the result of a dynamic interplay between wave action and the local geology. And so the waves come in, they have a lot of energy, they're able to break away at the rock and sediment and not only erode it but also deposit it to create these crazy cool different landforms. Speaking of crazy cool, hurricanes are not. They are crazy. They're not cool because they're driven by warm water. Ha! Get it? So, no. Equatorial regions, typically in the central Atlantic and central Pacific, where along the equator, water in the oceans is heated and that energy is transferred and creates a lot of moisture that is carried with winds towards coastlines. And in the case of Hurricane Sandy, this is a bit atypical in that most hurricanes will affect the southeastern United States. So like Florida all the way up towards the central kind of Midwestern states. Not Midwestern, sorry. Central and East Coast states like North and South Carolina, also the Gulf of Mexico area. So Sandy was atypical in that it hit the Jersey Shore and parts of Manhattan and lower New York City, and it was devastating because those areas are not only low-lying and at sea level, they're not accustomed to severe storms like hurricanes. So obviously you can see that they did a tremendous amount of damage. All right, so the shoreline, like I said, it represents kind of the interplay between erosion and deposition. It is the contact point between land and sea, and it represents kind of a flux between high and low tides. I'm not going to spend too much time on tides. If you are interested in learning more about that, I can definitely talk to you directly. But basically, this interplay is what creates really cool landforms on the edge of the continent. So we've got very diverse coastlines on the East Coast if you compare it to the West Coast. So I'm going to go ahead and talk about the East Coast. Like every summer, my family vacations in Delaware, the state of, not the county, in Ohio. And when we go to the beach is very broad. It has what's called a broad berm. There are dunes kind of at the back of the beach. It's a shallow slope, and that slope extends beyond where the waves crest out to sea in an offshore area. And that slope is really gradual. And because it's gradual and doesn't have so much of a slope, you tend to not get very big waves on the East Coast, except when you have storms, and storms kind of add a different variable to that equation. But if you go out west, you've got a different topography out west than you do out east, And there you're along active plate boundaries, especially in Northern California up through Washington, where you have steep offshore slopes that yield very big, crazy surfable waves. So different topography as you extend out offshore can result in different wave action. The more intense the wave action, the more erosional landforms that you're going to see. The less intense, the more depositional landforms you will see. All right, I'm not going to talk too much about foreshore and backshore. But beaches themselves, as you guys know, are an accumulation of sediment, and that sediment is constantly moving, and the beaches are constantly changing shape as a result. So sediment can be moved not only by wave action, but it can also be moved when you have rivers that deposit sediments closer to sea level, like in the form of a delta that we talked about last week. So you get deposition from inland river systems. You get sediment that's carried and deposited from longshore currents or wave action. And because of this change in the budget of sand being eroded and then deposited, you obviously get really crazy, cool landforms as a result. Storms add a whole different, like I said, variable to coastlines, in that frequent and forceful storms can erode entire berms or beaches. And so in some places where you've had heavy storm systems or hurricanes, they actually have to hire teams of coastal management professionals that redistribute sand, like in the form of dunes, which act as a protective barrier for some ecosystems, or they redistribute sand to form a broader berm for recreational use. The point being that we can't really necessarily control the natural budget, but we can control the unnatural budget of sand by, I don't know if you've ever seen like bulldozers on the beach, or quarrying sand offshore, these giant, that look like ocean liners, but or drill rigs that are actually quarrying sand from offshore and bringing it back to the beach to rebuild it post severe storm systems. So it's really interesting that this budget of sand. Sediment can be varied in size and shape and composition, obviously, because of what's being eroded or what's being deposited. In Hawaii, for example, we have a lot of basaltic rock, and that basalt is black, and it's enriched in iron and magnesium. And so when waves erode that black rock, you get cool black sand beaches. They're really, really pretty. They get super hot in the summertime. In other areas like Florida's Sanibel Island, you get a lot of shells from nearby coral reefs and different ecosystems. On the East Coast, you tend to get finer sediment, fine quartz sands. On the West Coast, in some areas, also in Maine and kind of the far northeast, you tend to get more gravelly grains because you have erosion of volcanic rock like granite that tends to be in areas that create kind of cliff-like formations, and that sediment tends to erode into bigger gravelly grains. So I'm going to stop here, and then my next part of this series on beaches and coastal areas, I'll talk about waves and wave action and where to surf. Yeah, right on, dude. All right, peace out.